Hello everyone. In this video lecture, we are going to discuss about multiplexer. So, in this concept, we are going to study about a multiplexer concept, how to design multiplexer, and also we are going to study and realize the 4 by 1 multiplexer design using 2 by 1 multiplexers and 16 by 1 multiplexer using 4 by 1 multiplexer. Let us look at the definition of multiplexer. It is a combinational circuit which have many data inputs and single output. This single output will select one of the data input as a output signal depending upon the selection lines. Suppose if there are n number of input lines are there, then we have log base to n number of selection lines are required. So that is, if there are 2 power n input lines, we required n selection lines. So example, so if there are 2 power 3, that is 8 input lines, we required 3 selection lines. If it is 32 input lines, that is 2 power 5, we required 5 selection lines. So this multiplexer is also known as data n selector, parallel to serial converter, or many to one circuit. So let us see what is the symbol and designing of multiplexer. So if you look at the symbol of 2 by 1 multiplexer, how it is being represented, there are 2 inputs, 1 selection line and 1 output. That is 2 by 1 multiplexer. So look at the truth table, how it works. So if S equal to 0, that is your selection line is 0, the input which is connected to 0 input is the output. If S equal to 1, then whatever be the input which is connected to 1 input is the output. So that is what S equal to 0, output is A. If S equal to 1, so because B is connected to 1 input, so Z becomes B. So if you elaborately write the same truth table, then if S equal to 0, so there is a 4 possibilities because of 2 variables 0, 0, 0, 1, 1, 0 and 1, 1. So whatever be the values of A and B, because S equal to 0, the output Z will take the values of A. So likewise, if S equal to 1, the output Z values are equal to B because B is connected to 1. Now look at the designing of simple 2 by 1 multiplexer. So as you know the truth table for the 2 by 1 multiplexer. So now we can go for Karnaugh map for solving the equation. So what is that equation? We get Z equal to, so S prime A as well as SB. So the equation can be get by doing the Karnaugh map method. So this is what equation. So now the implementation. So we require 2 AND gates and 1 OR gate. So S prime A and this is SB, and final equation is Z equal to S prime A plus SB. Okay, so this is how we can design 2 by 1. Now look at the same, go for the higher. So 4 by 1 multiplexer and 8 by 1 multiplexer. So 4 by 1 multiplexer, 2 power 2 is 4. So we required 2 selection lines. For 8 input, 2 power 3, we required 3 selection lines. So based on your selection lines S1 and S0, so the output Y is selected one of the input. So 0, 0, the output will select I0. For 0, 1, the output will select I1. So 1, 0, I2, 1, 1 is I3. So means out of 4, the output will select one of the input based on your selection lines. Now the same principle is applied for 8 to 1 multiplexer also. So in 8 by 1 multiplexer, there are 8 inputs are there, I0, I1 to I7, and 3 selection lines are there. So now if it is 0, 0, 0, the output will select I0 as a output signal. So likewise, if 0, 0, 1, I1 will be selected. So as that selection lines are changing, the respective I value, that is input value, will be selected. If it is all ones, it will select I7 as a output. So this is a simple concept of multiplexer. Then how to design higher order multiplexer using lower order multiplexer. Suppose if you have only 2 by 1 multiplexer. So I want to design 4 by 1 multiplexer using 2 by 1 multiplexer. So we should know what is a 2 by 1 multiplexer, truth table, as well as 4 by 1 multiplexer, truth table. So here, so we have to go with 3 2 by 1 multiplexer to design 4 by 1. So first I0, I1, I2, I3, total 4 inputs are there. So this has been divided into 2. So I0, I1 as 2 by 1 multiplexer with S0 as input as a selection line, and I2, I3 we are going to select S0 as selection line. So then out of these two 2 by 1 multiplexer, the output is connected to one more 2 by 1 multiplexer where the selection line is S1. So if you observe closely how the circuit is designed, so I0, I1, so this I0, I1, this S0 is changing 0, 1, and for I2, I3 this is changing 0, 1. So this is how we have to select at lower part of 2 by 1 multiplexer. So S0 is the selection line. So among these two, one of the input is selected as output. So among I2, I3, one of the signal is selected as output. These two is now connected to higher 2 by 1 multiplexer. Now here I must use S1 as selection line. Okay. Suppose, say for example, if I have given 0, 1 as my S0, S1 and S0. So what will happen in this case? Say S0 is what the input is I0, I1, and S0 is 1. So which one is selected? I1 will be selected here. Here it is I1. Now in this case S0, I2, I3, S0 is 1. So here I3 will be selected. So I3 will be selected. But what is S1 I have given? 0. So now here it is. This S1 value is 0. Now what happens? So the output will select the input which is applied at A. So what happens? So output becomes I1. Okay. So means that if you select 0, 1 selection lines, then you are supposed to get I1 as output. So the same is explained here. In the same manner, if you go with the 16 by 1 multiplexer using 4 by 1 multiplexer, so we should know what is a 4 by 1 multiplexer and a 16 by 1 multiplexer truth table. So now we have to divide these total 16 inputs into 4 groups, 4 different groups, I0 to I3, I4 to I7, I8 to I11, I12 to I15. So now the selection lines are the lower order 4 by 1 multiplexer selection lines are S0 and S1, and higher selection lines are S2 and S3. So if you do like this, say for example, if you select one of the example for understanding this. Say suppose if I select 0, 1, 1, 1 case. So what will happen? S1 is 1, 1. So both are 1, 1 here, here, and for all the places 1, 1. So this output is I3, this output is I7, second output is I7. So next output is I11, the next output is I15. That is total 4 inputs will come to this 4 by 1 multiplexer. But here what is S3, S2 is 0, 1. So 0, 1 means this multiplexer will select the input which is applied at the first input. So this is 0, 1, 2 and 3. So the first input which is we are getting as input I7. So output becomes I7. So this is how we can design higher order multiplexers using lower order multiplexers. But the thing is you must be careful with the selection lines which you are selecting for lower order as well as higher order. So with this we'll end the multiplexer concept. Thank you.